Yeah. Thanks everybody for being here. We really appreciate it. Spending the time with us today. My name is Jonathan Woods. I'm a solutions architect at AWS. And what we're going to be talking about today is making web applications fast and secure. This partnership with TrackIt is going to be a discussion around what are some of the services and offerings out there that AWS has. And then specifically, TrackIt is going to walk us through some of the offerings they have with a presentation and a demo. So we're going to start by giving kind of an overview of what are the applications you have today and how AWS addresses some of the needs and challenges that are out there. Many of the challenges we see today on customers' applications revolve around really four main issues. The first is the ability to scale to a global audience. And long gone are the days of your customers accessing your website from a single location or geography. Customers are spread across the globe and expect your applications to be accessible wherever they go. On top of that, routing customers over the internet is less than reliable, making it all that more important. Another challenge is as customers access your application across the globe, they expect fast load times. Studies show that over 50% of users expect a slide to load within 3 seconds, or they're going to go elsewhere for their traffic. The flip side of that global footprint is needed for your customers is having a secure application against distributed denial of service or DDoS attempts and bot attempts. With around 47% of all traffic being from bots, it's important to have protections knowing how good or bad the bots are that are hitting your applications. And lastly, creating a great end user experience is what we all want. The challenge is already hard enough as a business, moving from good to great, but having a good experience for your customers can have good or bad consequences in the long term. To address all these challenges, AWS offers the ability to deliver for your customers. What this means is that we create services and features to address the challenges just discussed, but did them in a way that's secure and reliable, scaling to your needs with top performance, packaging all this with cost in mind, and making it easier for your team to manage and execute. How did we do this? Amazon CloudFront is a content delivery network service built for high performance, security, and developer convenience. With CloudFront, you're able to reduce latency by caching your content closer to your end users around the world. You get some out-of-the-box protections for your applications or options to implement security against DDoS attacks, bots, or malicious actors. The ability to consumer requests and response from your end users on the fly, which balances cost, performance, and security, while also being able to cache content through our edge locations to your end users, ultimately saving you money and resources. So how does CloudFront work? Or better yet, how are the 4 challenges we discussed earlier addressed with CloudFront? By using the AWS Edge networking with over 600 points of presence or POPs and 300 regional edge caches, you get the ability to deliver and cache content closer to your end users around the world. By using these POPs, you're caching all or some of your application's resources closer to your users. You reduce the backend request to your application, which is ultimately going to save you cost and resources. So what does this all mean? By using CloudFront, you get the ability to scale and deliver for your customers while resting assured of the out-of-the-box protections it comes with. Maybe you understand the scope of today's landscape and the threats out there. Maybe you understand the benefits of using CloudFront already, but you joined this webinar anyway, but you still want to know what common applications utilize CloudFront for workloads. To get started using Amazon CloudFront, let's look at 4 scenarios where it would be beneficial. The first one, for applications that deliver static or dynamic content, CloudFront's going to benefit you out of the gate to deliver content to your users faster and cheaper than before. If using APIs, you can optimize dynamic web content delivery with supporting edge termination and WebSockets, creating a better end user experience. By utilizing CloudFront, you can stream quickly and with consistently deliver video on demand or live streaming video using an HTTP origin. And this allows for smooth streaming and delivery for your application's users. And lastly, with software patch downloads, you can scale automatically to deliver software, game patches, and IoT over-the-air updates at scale for your applications, creating a better experience for your users. Obviously, there are many more options for using CloudFront that provides safe and secure content. And if we were to stop there, you would have the out-of-the-box protections, yet those protections might not meet the needs of the vast threat landscape that you have on your applications. And to address this, Amazon has created services to complement the security protection at edge. So shifting to the additional features and services that complement CloudFront, let's assume you're ready to get started and implement CloudFront. Where do you go from here? By using CloudFront, you're getting those common needed protections out of the gate, but we know that threats are always evolving and changing. The threat landscape for the web applications out there is getting more and more sophisticated. Attackers have many tools at their disposal and can use botnets to deliver the attack payloads. Some of these attacks today revolve around DDoS attacks, as we mentioned before. And these attacks typically use techniques such as SYN flood or UDP reflection amplification. These attacks typically require large amounts of resources, which cause issues with your customers. As applications become more and more direct, as attacks become more and more direct, threats revolve around attackers trying to find vulnerabilities within your application. Application attacks are launched to compromise the server and to steal your data. Some of the common attack vectors include SQL injection, cross-site scripting, or command injection. And lastly, bots typically, again, take up 47% of the traffic on the internet today. And although not all bots are bad, they can be used very efficiently to perform site scraping, inventory grabbing, and credential abuse, which causes all kinds of headaches and security risk for your applications. To look at these threats, Amazon has a toolbox of services to help address this. And remember how we talked about the POPs earlier before? Well, with CloudFront, you're already pushing that attack surface out to the edge so that in many cases, your core resources aren't being burdened by having to be served by that attack traffic. And with Shield Standard on those POPs, you're also benefiting from automatic DDoS protection for everything, but the more sophisticated attacks, as we just discussed. Some of those services that add that additional protection are AWS Shield Standard and Advanced, AWS WAF or Web Application Firewall, and AWS Firewall Manager. AWS Shield comes in two flavors. Shield Standard is what you get out of the box, as we've discussed, and it's free of charge for any user. By utilizing services like CloudFront, you're getting that protection against network and transport layer threats. But with Shield Advanced, customers get more protections and options for your application for DDoS types events. AWS WAF or Web Application Firewall is a service that helps protect your web applications or APIs against common web exploits and bots that may affect availability, compromise security, or consume excessive resources. And lastly, with AWS Firewall Manager, you get a secure management service that allows you to essentially configure and manage firewall rules across your accounts and applications in AWS organizations. With these findings, you get complete inline control of your traffic to protect against unauthorized access, potential vulnerabilities, and perform degradation. This includes stopping common web exploits to advanced DDoS mitigations that help you protect your applications from the ever-growing attack types we just discussed. So let's look at how AWS WAF or Web Application Firewall works. A web application firewall lets you monitor the HTTPS requests that are forwarded to your protected web application resources. WAF does not require a proxy or TLS setup, given that architecturally it is integrated into each host service. In the simplest sense, you get to define your security posture, telling the service what you want to block and filter, and then monitor your traffic using other services like AWS CloudWatch or other logging services that you currently use. And just to show more of how each of these services are connected, we integrated AWS WAF with AWS Firewall Manager for cases where you need to manage multiple WAF deployments across multiple accounts within your organization at scale. As mentioned earlier, AWS Shield Advanced is a premium DDoS protection service that's available for customers protecting their resources with additional features as compared for Shield Standard. And these services include: 1, protection not just against layer 3 and layer 4, but layer 7 for your application. Near real-time event alerts with DDoS events or when DDoS events are detected on your protected applications. 24/7 access to the AWS Shield Response Team, or SRT, to help with mitigating attacks in real time. And cost protection on your infrastructure as it absorbs DDoS events. Part of that application layer protection at layer 7 involves automatic mitigation for your applications. With AWS Shield Advanced application layer mitigation, you get protection against DDoS events with no manual intervention needed by you. When you protect your resources with AWS Shield Advanced and enable automatic application layer DDoS mitigation, Shield Advanced will identify patterns associated with layer 7 DDoS events and isolate the traffic while automatically creating AWS WAF rules in your web application control list, or ACLs. These capabilities enable you to quickly respond to and mitigate DDoS events which threaten the availability of your applications. If needed, though, AWS Shield Advanced provides access to the AWS Shield Response team. The SRT team is comprised of highly skilled individuals monitoring your protected resources within Shield Advanced from malicious DDoS attempts. Their whole goal is to protect the availability and performance of your applications. And depending on the type of DDoS event and the architecture of your application, the SRT team can do one of the following actions. For resources that use AWS WAF, the SRT team can analyze your WAF logs to identify attack characteristics in your application's web request. And with your approval during engagement, the SRT can apply changes to your web ACL or on the WAF to block the attacks that they've identified. The SRT team can also write custom mitigations for any infrastructure layer attacks. The team will work with you to understand the traffic that's expected for your application, and then to help block unexpected traffic and to optimize packet per second rate limits. Third, they also work closely with the AWS networking teams to protect Shield Advanced customers. And when required, the AWS will change how the internet traffic arrives on the AWS network in order to allocate more mitigation capabilities for your application. And lastly, with 24/7 proactive event response through proactive engagement, you can rest assured your applications are protected from any threat. We've discussed a lot today in a short amount of time. We've discussed about how CloudFront adds the ability to deliver faster, more reliable, and more secure content for your end users. We talked about the protection you get with CloudFront, but also how the world is changing and having key services like AWS Web Application Firewall, AWS Shield Advanced, and AWS Firewall Manager allow you to confidently move into whatever is next. But how do you start? What's the first step? And as you get started on your journey or go through thinking through the implementation of these services, it's important to collaborate with organizations and partners with your security top of mind. And one of those partners is TrackIt. They deliver the ability to help fine-tune all these services and offerings for CloudFront and our edge services. And with their help and expertise, you can rest assured that you're set up for long-term success. And with that, we're going to go to the team now to hear some more about what they're offering.
Thanks, Jonathan. Really appreciate it. Let me go off and share my screen. You see my screen? I hope. All right, I appreciate it. Thanks a lot. So we're going to continue on with Jonathan's excellent introduction. I think you'll find that Amazon has really industry-leading tools and capabilities for content distribution. However, with all those tools that are available, very often a partner like TrackIt can come in and not only implement faster and using more best practices in a faster way, but also maybe bring additional capabilities and tweaks that might not be immediately apparent because the tools really are very powerful. Here's who we have on today. Thanks, Jonathan. You already spoke. So I'm Brad Winnett. I'm the president and one of the partners at TrackIt. We have Victor Jubilee on with us. He's one of our senior solution architects, and he specializes in content delivery networks and has done many customer engagements around CloudFront as well as the security stack. So we're going to get into it. So first, who's TrackIt? We're what's called an advanced tier services partner for AWS. Essentially, we're a systems integrator who specializes in standing up AWS pipelines and workflows and infrastructure. We do a lot of edge-related kind of work, a la CloudFront, Shield Advanced, WAF, but also we have a deep specialization in media and content pipelines. And what we found is that as the world moves to a richer content kind of place, the combination of our capabilities, not only at the edge, but also in feeding the edge through other content pipelines and workflows is advantageous to our customer set. So I'm going to talk about that a little more. Then we're going to talk about 3 case studies that I think are really will really be the meat of the discussion. And Victor is going to provide a brief demonstration of setting up CloudFront and WAF. And then we'll have a little time for Q&A afterwards. So we're in our 10th year as an AWS partner. We're located in Los Angeles, California. We have teams on the West Coast of the United States and Brazil, and a large team in France. And besides from setting up lots of pipelines in AWS, we also build a lot of cloud native software that runs on AWS, almost always, with all the requisite service delivery capabilities and competencies you'd expect from an advanced partner of AWS. I mentioned this before, 3 main areas where we focus. Media workflows, software development, security. Security is sort of stakeholder, I would say. However, especially in the media world, we deal with people like like movie studios and other people who are very security conscious. This has been a core part of our business. After 10 years, we have very nice client list that we're pretty proud of. They range from large enterprises like Paramount and CBS to mid-range companies to those born in the cloud companies as well, especially a lot of born in the cloud streamers or sort of next generation content providers, which is really one of the core spots where CloudFront and CDNs fit. All right. Enough the marketing part of the presentation. I thought we'd transition and talk a little bit about some of the case studies. So I'll give a quick overview, and then I will let Victor pipe in as well with a little more technical detail on each of these. Medici.TV is an interesting company. If you're a classical music fan, you probably know them, but they sort of bill themselves as the Netflix of classical music. They have an extremely large library of concerts, operas, all around classical music that they stream via VOD or also live stream. They have been around for quite a while, starting out with strictly audio and now into audio and video. They did have multiple issues, mainly based around quality of service, I would say. When you're playing classical music or showing concerts, it's really a very discerning audience. So you need, and they stream in high quality, you need high quality streaming, and it's across the world. And in particular, Medici was having problems in various regions, Australia, Southeast Asia, South America, sort of the lesser served environments. They were having lots of customer complaints. So part of what we did is we really tried to get in and optimize latencies, quality of service. And I will comment one more thing, which is interesting with Medici, and then I'll let Victor speak a little bit. As they grow out their services, looking at the very large bag of things that AWS can offer, sort of next up for them is to institute or instantiate the recommendation engine for the clients. Obviously, you get this on somebody like Netflix, but now that kind of capability is becoming much easier to implement on the second level streamers, especially with the advent of really strong AI tools to be able to understand customer sentiment and what they're watching and provide good recommendations about what they should watch next is becoming very common across the board. So that's sort of the next thing up for Medici. Victor, you want to make some comments here about what actually we did here?
Yeah, sure. So yeah, it was a really interesting project because of the different problematics they had. So as I said, one problematic, the big one was the quality of service concerning the quality of the video they were serving. They were using a third-party provider to do the transcoding, and it was under the quality they were expecting. And so the first step was to migrate all of that workflow to AWS. And they also wanted as well more control over that process and to centralize it with the rest of the infrastructure, which was in AWS. So we had to migrate all of that process, create VOD transcoding pipeline in Media Convert that converts everything. We validated the quality with them and stored everything on S3. And then the next step of that process was to migrate the CDN solution to CloudFront. And also to, in the same time, alleviate the issues they had with some regions like Brad says, Southeast Asia and Australia. And so we created some CloudFront configuration to enable multi-origin in different parts of the world and help us with all of the issue with latency for all of their users.
Thanks, Victor. Yeah, so Medici is kind of a very stereotypical case, especially for early on users who are those who are really might be scaling, where they're finding that they have greater reach than maybe they had initially planned on, especially geographically. And the quality of their content becomes more and more important. So very much a stereotypical case about how, especially around how the tools available within AWS can help with that. In this case, it wasn't just CloudFront, but it was also the rest of the media tool capability that's in AWS. Let's move on to the next one. So X-Rite is an interesting company. This is the company behind the Pantone color palette, which if you've ever painted your house or recently painted your house, you probably know about when you walk into a paint store and they say, well, what color do you want? And they give you a palette that's generally Pantone. And besides from managing that part of it, they build a bunch of tools and capabilities around making sure that the colors that somebody purchases or uses are actually what they're supposed to be. Color matching is very important. So they have a variety of products, spectrophotometers, densitometers, colorimeters that they supply either as actual hardware products or as services over the internet. They had been on Akamai, and I don't think they were getting, frankly, the love that they had expected from Akamai, and they weren't getting the performance nor the service that they felt they needed as they grew their over-the-air services. So part of, I won't call it a challenge, but part of the process of moving from another CDN to AWS CloudFront is really understanding what particular features and capabilities are needed moving from one CDN to the other. Because you might have built some of your services around what your previous provider gave you. And CloudFront and associated services are just it's a big bag of tools that let you do things, often case in very fine-tuned ways to build these additional capabilities. So migrating from Akamai to CloudFront, there needs to be a bunch of discovery about exactly what's being used and what we have to recreate or improve upon when we move to CloudFront. I think the other one, and I'll let Victor talk about this in a second, is that it's an interesting one because their origin is actually on VMware Cloud, which we don't see too often, but it does speak to the ability to have a very lots of different types of environments that you can serve through CloudFront. Victor, you want to go ahead?
Yeah. So as Bob just said, one of the interesting part of that project was the origin that wasn't present on CloudFront on AWS. Sorry, and so we had to work with that to enable some authentication between the origin and CloudFront to make sure that the traffic isn't intercepted or anything like that and is secured. They also had some custom behaviors that were needed to be migrated from Akamai. things like vanity pages that redirected to certain URLs which were done by the CDN. Things we had to implement using CloudFront functions. They also had a big WAF configuration set up on Akamai. So we had to look at the rules they were using, the rule sets they were using, figure out their equivalent on AWS WAF, as well as replicate what the custom rules they built, and then be able to test all that and make sure that the migrated infrastructure was up to par as the ones they had before, and make sure, yes, that everything was working correctly.
Yeah, just a couple other quick notes. They did have quite a few domains that had to be moved over, and they were very concerned about the cutover process. We spent an inordinate amount of time with them, making sure they had a very clean cutover, and that includes not only the domains but also the routes and everything else. So it was a very comprehensive cutover planning that went along with them. Very successful. So let's go to our last case study we're going to talk about. Actually, also another really interesting company. So Pelmorix, they're a dominant provider of weather information in Canada and in fact in North America. They, as you might imagine, if you're looking at a weather site, the web page is very complicated. There's lots of things going on. You've got video, and you've got graphs moving. You've got tickers. I mean, there's all sorts of things going on in this web page. So it really is a quite involved site with lots of really great information. It's really, if you're into that, really cool information. They had a very sophisticated Akamai environment that we migrated to. And we had to do a bunch of work with CloudFront functions and also Lambda at Edge. And maybe Victor can speak a little bit more to that, because Lambda at Edge is really a very powerful capability. I don't think it's really widely understood, especially if you're coming from somebody like Akamai. But the ability to run your own code at the edge to do specific things can be very, very powerful and very enabling. So with that, Victor, you want to?
Yes. So for this project with Pelmorix, so as Bud just said, we had a lot of custom behaviors that were needed to be migrated over to CloudFront, leveraging CloudFront function that was a Lambda at Edge, which are both ways in CloudFront to be able to run code at the edge every time a request comes in. And we had to do some work to do some dynamic URL rewriting that they were using, as well as some like header modification, cookies, dynamic cookies modification. And we had to integrate a lot of that into Lambda at Edge CloudFront functions. Also, as well, they had a substantial amount of different domain names. And we needed to make as well an infrastructure as code configuration to be able to make it really easy to expand, because they were planning on having multiple websites, multiple domains added. And that's something that wasn't possible to do with Akamai. Everything was done through the console. You couldn't do anything like check it in a Git repository or anything like that. So they also gained control in that everything now in that infrastructure was done through config files that were checked into a Git system, and which enabled them to have a lot more control over that. And we also migrated some WAF rules as well, same as with X-Write. We needed to see which one were actually needed and how they translated to AWS WAF.
Thanks. And that's actually, there's a couple of really good points in there. One, just to reemphasize, using CloudFront, you can build overriding infrastructure as code where you don't have to go to a specific console for a specific service necessarily. So, in many environments where we work, it's not just CloudFront, but there's other things that are being used in AWS in the pipeline to feed the content delivery network. and the ability to write infrastructure as code across these different services that are available in AWS is really powerful. We're a big believer in infrastructure as code, and especially as you use other services I mentioned earlier before, like being able to suggest content at Medici TV recommendation engine. That could also come under infrastructure as code, so you can take your whole environment and really automate it versus having to go to multiple tools to manage different parts of your environment, as you would with use like a standalone CDN like Akamai or one of the others. The other thing, I don't think we really talked about it. I'm not sure how aware the audience is about what Lambda is, because we spoke about it a few times. So Lambda is a serverless compute service from AWS. This essentially allows you to write small bits of code without having to dedicate an actual computer or computer instance to do it. So you write a piece of code and submit it to AWS. It's extremely efficient, extremely fast way of executing a piece of software. And Lambda Edge is specifically around being able to execute that code at the edge where it's very, very close to the user. In the case of a CDN, very powerful way to extend the capabilities and performance potentially of a CDN that's not really available for most of the competing providers. And I think with that, I'm going to hand this over to Victor, who is going to give you a little demonstration.
Yeah. So first of all, we're just going to give you a quick overview of what we'll demo today. So we'll demo how we can leverage edge services from AWS, specifically CloudFront and WAF, to help you with increasing the performance of your website as well as securing it. So let me just share my screen. Okay. So to start, for this demo, created a simple website, simple demo website. So what this website does is every time you load it, you get a new quote. So you get a new random quote every time you load it. You can also search a quote by author's name, and you get the author. So it's pretty simple website. It's a dynamic website, meaning that every time you reload, the content changes. So you can easily just cache it to help with performance, and we'll see about that later. And so first of all, we just see what are some of the challenges when you host a website. Because for now, this website is hosted just on an EC2 instance in US West 2, so in Oregon. It's served behind a load balancer, but nothing else is done beyond that. And currently I'm in France, so it's quite a way between France and Oregon. And we'll be able to see that if we look at the latency when we load the page. So if I reload the page, I can see that I am almost at half a second to load the page of my website. And if we dig a bit deeper into that, we can see that most of the time we spent getting this web page is actually lost in the initial connection phase of the request. Because when you do a request to a web server, it's not just sending one-time information and then it will give you a response. There is actually more layers to that because first you need to establish what's called a TCP connection. And for that, you need a lot of back and forth between the client and the origin and the server. And so if we are close to our server, we don't see it. But if we start getting we can start getting more far. The latency between the two compounds exponentially. So that's why even if you have a 60-80 millisecond latency, because you need to do it like a lot of round trips when you load your page, it starts getting way too high. So for this simple website, now we're going to see how with CloudFront, we can just simply gain a lot of latency and performance just by enabling CloudFront. So for that, I'm going to head over to AWS account, and I'm just going to go to the CloudFront console. And so from there, I'm just creating a new CloudFront distribution. So because our server is already on AWS, and the load balancer is some in the origins that is handled by CloudFront, I can just search from my Elastic load balancer, say, okay, I want to use this origin. We leave everything at default here. Same here, we just gonna change a couple of things. We're gonna allow all the HTTP requests methods, because as we can see, when we want an author's name, it's a post request, so we need to enable that. And also something pretty important to do is the caching policy. So that's telling CloudFront how you want your page to be cached. Because usually a CDN, what it does is you request a web page, and it stores it in its cache. And then if you request the same web page later, instead of sending back the request to the origin, it just serves it to you directly. But because our website is dynamic, we can see when we reload, we get a new web page. We can't use any caching, because otherwise it would break it and just return the same web page every time. So for the caching policy, we're gonna say caching disabled, because we don't want anything to be cached. We're gonna enable the security protections for this distribution. So it's gonna enable some WAF rules automatically for us. And then everything else we can leave to default, can create it. So our distribution is created. Now, because CloudFront distribution usually takes between 5 and 10 minutes to be created, in the interest of time, I've already created one from this demo. And it's everything the same configuration as the one we just did. So now if we take our distribution domain name and we try loading it, we can see, okay, our website is served through CloudFront, because I can see the URL is from CloudFront. So for now, it doesn't seem like a lot has changed, but let's dig deeper into the website and see if we gain some time when loading. So we get our web page. We can see that, okay, we've almost lost 200 milliseconds loading time. So looking back at our other website, we can see, okay, it was 533. Now we are just 300. And more, actually, if I do this, no. And even more interestingly, we can see that we, yeah. So we can see that we dropped our TLS time. It's only now 239 milliseconds, where it was almost 345 before. And that's due to the fact that our back and forth, so as we talked before, the start of the connection, the back and forth between the server and the user, now instead of happening between the user and the origin, which is in Oregon, now it's happening between the user and the CloudFront point of presence. So the server that's having the request that's distributed all over the world. For us, we can actually check. CloudFront is telling us from where it's having the request. It's X Amazon CF POP. It's using the airport code. So CDG is Charles de Gaulle. So we know it's from Paris. So the timing, the back and forth that goes on between the user and the server now is between the user and the point of presence. And so the latency is really low between them. So all the back and forth goes really quickly. And you can divide by 10 or 15 the initial connection time between those. Now with CloudFront, there is another way also to gain some speed, because for now, we are not using CloudFront to its full potential, because we are not caching anything. And as we said, we cannot really cache the website, but there is something we can cache on the website. And that's every time the web page is loaded, there is a photo. There is a picture of the guy who said the quote. And this picture, if we look at it, it's just stored under images and the name of the guy. And so we know that every time you request something on this URL, you will always get the same thing back. You will always get the same picture. So we can tell CloudFront to cache those pictures. And we can do even better and leverage even more of the AWS infrastructure. Because if we go one step further, we say, okay, but if those images are always the same, why do I need a web server to even serve them? Like if I could just store them somewhere and tell CloudFront to go there when it's under this path, it would be even better. And that's something you can do with CloudFront is leverage the leverage S3, which is object storage in AWS. Just a place when you can upload objects and then fetch it back. And so what we've done for this demo is we've taken everything that's stored under this folder and copied it to S3. And now we're going to configure CloudFront to tell it to take those images from S3 instead of sending the request to the web server. So to do this, we go back to our CloudFront distribution. We'll go to the origin tab. And for now, the only origin we have is our load balancer. So we'll create a new origin and point it to the S3 bucket where we stored our images. So we do it here. Nothing else need to be changed there. So we're good to go. So now we just configure CloudFront to tell it there is another place where it can look for the data. And now we need to configure the rules for it to access this data. So for now, we only have one rule. It's a star rule that englobes all the traffic that disables the caching. So we create a new rule and we say everything under images, so images / star, we don't want it to go to the load balancer, we want it to go to the S3 bucket. So we go to the S3 bucket. It's already filled up the caching policy for us because it's from S3 origin. So we don't need to change anything there. We can just create the behavior. And so now we just wait for it a few moments to deploy. And so just something we did to make it easier to see that the images are coming from somewhere else is that all the images on S3 are actually colored green. So you'll be able to see them. So, okay, we can see that now our images are loading from S3. So for now, if we look at the time it takes, we can see it's almost 130 milliseconds. And if we look at how it was with the web server, it's 191. So it's not a lot of gains. But that's just because we just requested for it once. Because we like how caching works with the CDN. So you request for it once, it stores it in its cache. And if you request for it again, you get the new version. So if I tap just to get the same, okay, so now if we look at it, it only took 48 milliseconds to get the image because it was cached. So, and we can actually see that from the headers in CloudFront. We can say hit from CloudFront, meaning the cache was it was found in the cache. If you look at the one before, it was missed. And so we see just with some quick configuring for static assets, we can greatly increase the performance of our load times, especially for images, because that's assets that are pretty heavy. So it makes sense to cache them close to the user. It would take shorter to download. And we can see it greatly increase the time it took to get those images. So that's pretty much done for the part of performance with CloudFront. And now we're going to see how we can leverage CloudFront and Web Application Firewall to help you with security. So I will just need to delete this route for the security part. Okay, so CloudFront now has a security tab that allows you to have a quick overview of your distribution metrics for security as well as bot protection. So we'll start with the bot protection. So before I talk, I will just generate some bot traffic, so we're able to show it to you. Okay, so I'll just request just do 20 curl requests for our web page and just let it run. Okay, so as Jonathan said before, like a big a lot of traffic in the internet is coming from bot. And the issue with bot is that you can just deny all bot traffic because that would be bad for your website. Because you have some good bot traffic, like for example, crawlers for search engines, things like that you want to keep, but you also have bad actors, things like just scraping all of your websites that can not just degrade your level of service and performance, but also degrade you in a business way because grabbing all of your inventory, reusing your content, stuff like that. So one of the issue with bot content is not actually addressing it, but identifying it and separating it. And the security tab on CloudFront actually makes it pretty easy because as we can see, now I just did 20 bot requests, and we can see they got detected by CloudFront, and we can see it categorized the bot request. Says okay, I got HTTP library, signal, non-user browser agent. So this is telling me okay, this is not coming from a web browser, and what do you want to do about that? For now, it's just monitoring it and reporting what it sees. But what's enabling us to do in this tab is also quickly act on it. So if I say, okay, I just got a spike in bots coming from this kind of category, I want to do something about it. And now we can just do something about it, clicking here. We have multiple options. We can allow the request, block the request, or send the captcha or the challenge to the user. For now, we're just gonna block the requests. Just say, okay. We block them. And now, if I try to get the request again, okay, it takes a bit of time to enable it, but after a while, yes, after a while, we get this. So this is a 403 error by CloudFront, and it's it's denying the request. So now I cannot request anymore the website using curl, or for example, like a Python script or things like that. So that can help you to take quick action, to identify quickly, and then to swiftly take action about those threats in anything related to bots. So that's the bot side of part of things done. Now we're gonna see another type of problem that an attack vector that can be helped by the web application firewall. So the AWS Web Application Firewall is a full-fledged product with a lot of configurability, managed rules provided by AWS, as well as custom rules you can do. But by default, a subset of those are available through the CloudFront console directly. Those are core protection, SQL protections, and rate limiting. Core protection encompass a base of everything that you want. It's had a lot. It's usually a good base to build upon. You have SQL protection, which protects against SQL attacks, and rate limiting, which protects against HTTP denial of service. So to show you how those protection work, on the website, we have those two buttons, SQL and XSS, and what they do, they just fill up this form with some common SQL attacks and common XSS attack. So SQL attacks quickly are a way to exploit when a web server is using a database to generate its content, and you have a field, and the value of the field is used in the database to get the data back. You can exploit some, if you have some misconfiguration on your web server side, you can exploit that and gain access to the full database. And this is done with those type of requests. And for now, if we try it for now on our website, we see it's doing nothing because it's not connected to a database, but it's not blocked or anything. Same with cross-site scripting, it's not blocked at all. So now, because those protections are in what's called monitor mode, so same as the bots, they won't block anything unless you tell them to, and they will just report that they are seeing something. But what we can do is we can enable blocking for both of them. And same, we'll wait for a bit for it to propagate and to be enabled. Same as with the bot protection, it takes about half a minute to be set up. But now you can see we get the same error as the bots. We got a 403 errors, meaning CloudFront blocked our request. And if I try the cross-site scripting one, same thing, CloudFront blocks that request. And so that's the overview of the security side of things that you can leverage with CloudFront. You can go deeper into it with AWS WAF, the full-fledged product, as well as what was being talked before with AWS Site Shield, which can help you more with DDoS attacks. But that's some basic overview of how you can leverage CloudFront and the WAF to help the performance of your website, to help it scale globally and be distributed to all of users. And while doing so, being made sure that you're not more vulnerable by putting your website out there. So I think I will I'll hand it over to Brad, and if you have any question, please don't hesitate.
Thanks, Victor. Appreciate it. I'm going to share my screen one more time. Kind of wrap up, and then we'll ask for some questions. And I do see we at least have one or two. If you'd like a little more information directly about helping you either onboard into CloudFront or implement some of the security features that Victor walked us through, we do have some packaged offerings to help do that, including Shield Advanced onboarding, which includes some WAF and some custom rules that we'll build for you and other things. Fairly complete offering. Always happy to have those conversations. So I do see that there are a couple of questions. So maybe we take the first one first. How long does it normally take to migrate to CloudFront? And I would say it's definitely variable depending on how many domains you have, custom rules you want implemented, how much we want to customize and optimize. I would say, just from a general rule of thumb, by the time you do some really good, we do some really good discovery about what's necessary and where you're coming from to where you want to go to. The discovery can take a week or two, implementation another week or two. So I would say in the range of between 3 weeks and 2 months, really depending on how complicated the environment is. And if it's only on the CDN and the security part of it. Obviously, if we're moving other workflows, those have to be looked at individually. Let's see. Now the other one is actually kind of the same question, so we don't need that one. However, I do see that Jonathan put up a survey form, so I would ask anybody on the call to please go out and fill that survey. You can find it in the chat area. And I'll leave it open. Does anyone else have any other questions or other comments? Jonathan, Victor.
No, I appreciate everybody being here today. Definitely reach out to TrackIt or myself. Our contacts are on the screen if you need any more information about what we talked about or any clarity. Happy to help in any way we can.
Yeah, thanks so much for your time. Hopefully it was informational, and we'd love to help you out in the future. Thank you so much. Have a great day. Okay. We'll call it there then. Thank you so much. Bye-bye.